Pleasant morning to one and all. Today the topic for my video lecture is an introduction to database management system concepts. I am Karthikeyan, working as an associate professor in Department of Computer Science and Engineering, PSNA College of Engineering and Technology, Dindikal. So before we just move into the presentation, we have to understand what is DBMS. So for understanding the concepts of database management system, let us just move back to the olden days, how the enterprises may store the information for their easy access. You just consider an enterprise such as educational institution or a company side. If they want to store an information, in your olden days they use the paper documents. If the time will grow, the size of the documents will be getting enlarged. So the maintenance of documents is a very difficult task. So that when the computers comes into the field, they are storing the information in a file management system which is managed by the operating systems. After some time, the people who are working in various enterprises, they feel there are some limitations in a file management system. So to overcome the limitations, the research is undergone in the field of file management system. They have discovered the concepts of database management systems. So that by means of the database management system, they can store the information as well as they can retrieve the information in the easiest way as well as an efficient manner. Today, in this video lecture, we are going to see the purpose of database system, that is why we are going for database system, and what are the different levels of abstraction, and what are the different types of data models, and then what are the query languages which can be used to retrieve the information from your database, and finally we are going to see the various applications of database system. So let us consider first the purpose of database system. So for understanding the purpose of database system, let us analyze what are the various limitations of the file management system in the legacy model. So the first limitation is data redundancy and data inconsistency. So first of all, we have to define what is a redundancy and what is a inconsistency. You just consider an redundancy is nothing but like the repetition of same information in various places. For an example, if I want to store a customer information for a particular enterprise, you just consider our PSNA College of Engineering and Technology. The students are our most valuable customers. If I want to store the customer information in a file system, okay, suppose a particular student, okay, he is studying in Computer Science and Engineering department. I want to store an information about a particular student, okay. So maybe like the information about the students are register number, student name, department and address, telephone number, like that we will store n number of information about a particular student. If the same student may be staying in the hostel, okay, suppose in the hostel they are maintaining separate files for student, in college they are maintaining separate files for student. Suppose if you are storing the personal information of a student in a college file as well as in a hostel file, so maybe like the customer address and telephone number is repeated. Customer address and telephone number is repeated in a both college database as well as in the college file system, okay. So this is actually called redundancy, that is the repetition of same information. By means of this redundancy, the storage is wasted as well as it will lead to the more access cost. And then the next one is data inconsistency. What is data inconsistency is the various copies of same data may no longer agree. This is a definition of data inconsistency, okay. What do you mean by the copies of same data? Like I have already told, the student information is stored in a college file system as well as in a hostel file system. Suppose if the students wants to update the address and telephone number, so what happened? Suppose he is giving a requisition to college. is giving a requisition to college. So if the college is updating the personal information in a college file system, but that particular updation if it may not be updated in the hostel file system, this is called inconsistency. The second limitation of a file management system is difficulty in accessing data. What do you mean by accessing data? Suppose you just consider an enterprise, that is the same example what we have considered, our PSNA College of Engineering and Technology. If the head of the department is asking the tutor to retrieve the student details of a particular class, those who have scored above 80% in a particular semester. If the tutor wants to access those data by using the file management system, they have to write a separate application program. So they have written an application program, they have fetched the data for displaying the students who are all scored more than 80%. After some time, the HOD is asking, you have to retrieve the student details, those who have scored 80% in throughout all semesters. So now the condition is different. In the previous case, the HOD is asking the student details of the particular semester. Now he is asking the details of throughout the semester who are all scored 80%. So for that, the tutor is going to write a separate application program, so that the users of a file management system, if they want to access the data, they have to write n number of different application programs. In addition to that, the data are scattered in various files, various locations. So to access the data, they have to access the different files stored in various places, so that the writing of application program is a very difficult task. At one time, the number of application programs are very large in a particular enterprise, so the file management system is very difficult to access the data. The next one, data isolation. This particular point is correlated with the previous one, that is the data are scattered in various places, that is the data are isolated. Due to this data isolation property, the accessing data is not a easy task in a file management system. The next one is an interesting issue which is called integrity problems. What do you mean by the integrity problems? The integrity is nothing but an accuracy of your information. Suppose you just consider the registration number of your students of PSNA CET should start with 9213. You just consider any department, the student's registration number should start with 9213. So this is actually called one of the constraints for the registration number, that is the registration number starts with 9213. Suppose to maintain this constraint in a file management system, the programmers are feeling so much difficult, okay, because you just see the another attributes, like for example like a percentage. The percentage should be 0 to 100. The percentage should be 0 to 100. Like that, they have to impose a different application programs for satisfying the integrity issues. So the maintenance of integrity issues is a difficult task in the file management system. The next one is atomicity. So this particular issue called atomicity comes under the transaction management. What is a transaction? In day-to-day life, we are dealing with n number of transactions. Even the students are also involving with different transactions, like taking the books from the library, returning the books to the library, as well as they can do online transactions for banking, reservations, everything, okay. So in general, we can define a transaction. It is a collection of logical operations that can define a single logical unit of work. So behind every transaction, there will be a collection of logical operations. So when we are going to consider a transaction, if a transaction is executing, at the end of the transaction, the storage system will maintain a consistency. Suppose if the storage system is maintaining an inconsistency, the transaction is not a valid one. Just for an example, I am transferring certain amount from one account to another account. You just consider account A is consist of rupees 1 lakh, account B consists of rupees 50,000, okay. So the people, that is the owner of account A, is transferring rupees 10,000 from account A to account B. During this transaction, maybe some failure occurs. You assume there is some failure due to network failure or due to server crash, the transaction becomes failed. Okay. So now at the end of the transaction, you can see the value of account A is rupees 90,000, the value of account B is still 50,000. So it is maintaining a inconsistency state. Okay. So to ensure there is no inconsistency, we have to ensure the atomicity property of a transaction. So atomicity is nothing but either all the operations of transactions are successfully completed or none of the operations are successfully completed. So ensure the atomicity in a file management system is a great difficult task. Okay, so that we are just moving to database system. The next one is a concurrent access. So nowadays we are just going for the data can be accessed by multiple users. So what is the reason why we are allowing the concurrent access is to improve the performance or to improve the efficiency. We are just allowing the users to access the data simultaneously. When we are allowing the simultaneous data access, what happened is there will be some anomalies. So for handling those anomalies in a file management system is a difficult task. And then finally the security problems, that is not all the users of your storage systems can be able to use all the data. There will be some restrictions or there will be some authorization. For example, you just consider a banking system, the payroll department, that is the salary calculation department, they have to access only the employee of your bank data, but they will not access the customer's data. Like that, we have to provide a different levels of security. So providing a different levels of security in a file management system is a difficult task. So due to this 7 reasons or the 7 limitations of a file management system, if an enterprise wants to store an information, they are migrating from file management system to database management system. So now we are going to define formally what is a database management system. So you just consider a term database management system, we can decompose the term into 3. One is data, another one is database, and then third one is database management system. What is data? A data is a raw fact that can be recorded and it has a absolute meaning. Suppose you say maybe there's an example, you just consider a account. The account balance is one data, the customer address is one data, account number is one data. Like that, it is a raw fact. The next one is a database. Database is a collection of interrelated data about a particular enterprise. So we are going to store all the data in one particular location, that is called a database, that is a collection of interrelated data. And finally the DBMS. So by means of DBMS we can store the data as well as we can access the data in an easiest way as well as in an efficient manner by means of some program. So that the DBMS is a software which can be used to store the data in an efficient manner as well as for accessing and manipulation. So this is about the purpose of database management system, that is why we are going for database and what is a DBMS. The next is the levels of abstraction. Normally, what do you mean by abstraction? The abstraction is hiding the complexity. Abstraction is hiding the complexity. So according to the database system, there are 3 levels of abstraction. The lowest level of abstraction is the physical level. What do you mean by the physical level abstraction is how the data can be stored in a database. So for storing the data, we need some efficient data structures. We need some efficient data structures. By means of data structures, how the data can be stored. This can be concentrated in a physical level. The next level is logical level. In this logical level of abstraction, what kind of data we are storing and what are the relationship among the data. So here in logical level, I am just introducing a term called the schema. The schema is the logical design or the overall logical structure of a database. What data we are going to store in a database and what is the relationship among the data. This is a logical level. And the highest level, that is the third level of abstraction, is a view level. In this view level abstraction, there will be a n number of views, like view 1 to view n. Okay. So why we are having n number of views are, Suppose if I am creating one database, a database consists of huge information, but depends on the user, the information access may be varied. Suppose if the user is accessing some part of the database, then that may be a view1, another part may be view2. So depends on the user, the view is getting changed. So for that, the view level, there may n number of view levels are available in a levels of abstraction. So you just consider these three levels. The three levels are isolated from each other. That is, the end users who are in view level, they are not worrying about physical level. The database designer who are designing the schema in logical level, they are not worrying about the physical level. Like that, they are hiding the complexity among the different levels of abstraction. The next one, just now we have discussed what is a schema. It's a logical structure. There are two types of schema. One is a physical schema, another one is a logical schema. The physical schema is nothing but the design of the database at the lowest level. That means physically how the data can be stored inside the database system. So here the selection of data structures is playing a vital role in your physical schema. And then next one is logical, that is the overall design. What do you mean by the overall design is, suppose you designing the database, for that database what are the attributes are required, what are the data types of that particular attributes, okay. Like that we have to provide the overall architecture or the overall design of the schema. The next one is an instance. What is the relationship between schema and instances? You just take an instance, it's nothing but an content of the database stored at a particular moment. Suppose I am creating a student database, at time t1 I am having 1000 records. After some time the 1000 records may be increased to 1500 or 2000. So the content of the database is getting changed time to time. So that is called instance, that is the actual content of the database. So by comparing with the schema and the instance, the schema changes very rarely, but instances are getting changed frequently. Whenever we are doing a insertion or deletions, the contents of the database is getting changed, so these instances are changing frequently. This is about the instances and schemas. And the next one is a data model. Data model is an underlying structure of a database. What do you mean by underlying structure? For defining the structure of the database, the data model is providing some collection of conceptual tools, that is logical tools. Those tools are used to describe data, data relationship, and then data semantics and data constraints. So we know that what is data, and between the data there must be some relationship, and semantic. The semantic is nothing but a meaning of the data, how the data is meaningful in a particular enterprise, okay. So we are defining or we are describing the semantics of the data, as well as we are describing the constraints of the data in a data model. So it's a conceptual tool for describing these four things. In this data model, we are going to see about the two commercial data models they are using in a database theory. One is a entity relationship model, another is a relational model. So let us take first entity relationship model. That's an overview we are going to see. What is this entity relationship model? Entity relationship model is based on the perception of a real world that consists of the collections of entities as well as the relationship among the entities. So for understanding this ER model, we have to define what is an entity and what is a relationship. So you just consider an entity is a real world object that is distinguishable from one another object. You just consider a class. In a class, if there are 60 students, each and individual student is an entity. So in a class there are totally 60 entities. So the 60 entities are distinguishable from one another by means of certain properties, okay. That is called an entity. In this ER model, the entities are denoted by the rectangle symbol. In this ER model, the entities are denoted by the rectangle symbol. And then the next one is relationship. What do you mean by the relationship is association among the entities. That is how the two entities are associated with each other. For providing that association, we are just describing the relationship. So in this ER model, there are two entities. One is a customer another is a account. There are two entities. These two entities are associated with the relationship that is called depositor. In an ER model, the relationship can be denoted by the diamond symbol. The relationship can be denoted by the diamond symbol. Okay. So this ER model consists of two entities and one relationship. So you just consider this particular customer entity is describing by using the various properties like customer ID, customer name, customer street and customer city. Like that for account entity, they are having account number and balance. So when we are going to consider the ER model, this ER model is very much useful for overall design of a database. The next one is a relational model. This relational model was invented by the person Dr. E.F. Card. E.F. Card is actually the father of DBMS. He has described the relational model. In this relational model, the primary object is a table. So when we are going to store the data or when we are going to store the information, the data can be stored in the form of a table. In this presentation, we are just consider a account relation. This account relation is stored in the form of a table with three attributes. One is a account number, another one is a branch name and another one is a balance. So like that, when we are going to store any information, the information may be stored in the form of a tables because the table is a primary object of a relational model. So in this relational model, first we are going to see how the table structure or how the relation structure can be formed. So for understanding this table structure, let us consider first domains of an attribute. We know that what is an attribute. The attribute are used to describe a entity. Just for an example, customer means customer ID is one attribute, customer name is one attribute and customer address, telephone number, like that. Okay. So for each and every attribute of an entity, we are having the domains like D1, D2 up to Dn. So it's a n number of domain. What is a domain? A domain is a set of possible values or a set of permitted values for the particular attribute. So you just consider a definition of a relation. A relation R is a subset of Cartesian product of all the possible domains. Suppose in a customer table, I am having customer ID, customer name and customer address. If I want to form the table for the customer, I have to first perform the Cartesian products of all the domains, like domain of customer ID, name and address. Then I am going to take a subset. So you just take a relation or a table is a set of n number of tuples. All the tuples are belongs to the corresponding domain. So this is the definition of a relation or a table. In this relational model, the relations are unordered. What do you mean by the unordered is, you just see the first presentation, the account numbers are in the order like 101, 102, 201, 203 like that. But you just consider unordered, the account numbers are maybe in a different orders. So order doesn't matter in your relational model because the relations is using the concept of mathematical set. So the mathematical set doesn't worry about the order. So the same property is inherited to the relational model also. Next, in the relational model, we are going to see the concept of keys. What is the use of the keys? The keys are used to identify a tuple of a relation in a distinguished manner. What do you mean by the tuple is, the tuple is nothing but a corresponding row of a particular table or a corresponding record of a particular relation. So for an identification of a tuple in a unique manner, we are just going for keys. There are four types of keys in a relational model. One is a super key, another one is a candidate key, another one is a primary key and another one is a foreign key. So you just consider a super key. A super key is a set of one attribute or more attributes that can be used to identify a tuple in a unique manner. So you just consider a customer table, a customer ID may be a super key or a customer ID, customer name is a super key. So a table can have more than one super key. You just consider a candidate keys. Candidate keys are nothing but a minimal super keys. That is why we are going for candidate keys are the super keys may consider some extraneous attributes. What do you mean by the extraneous attributes? You just consider an customer ID and customer name is a super key. The customer name is a extraneous attributes. So to overcome that extraneous attributes, we are just going for the candidate keys. That means when you are going to take a subset of a super key, that subset will not be a super key. So that we are just going for a candidate key as a minimal super keys. The next one is a primary key. The database designer, they are selecting the primary keys from the candidate keys. So primary key is nothing but is a combination of the unique property plus not null. Suppose if we are defining one attribute as a primary key, it does not allow the duplication, it does not allow the null values. And then the next one is a foreign key. So for understanding this foreign key, let us consider this schema diagram. Okay, this schema diagram, you see in banking system we are having 6 different tables: branch, account, depositor, customer, borrower and loan. For an example, the branch name of your account table is referring the branch name of your branch table. So here a branch name in a branch table is a primary key. The branch name in a account table is a foreign key. So the table which consists of the primary key, which is called parent table, the table which consists of the foreign key is called child table. So we are maintaining a relationship between the parent table as well as in the child table. This is the purpose of the foreign key. And then the next one is the query languages. Okay, what do you mean by the query languages? Query languages can be used to access the data from the database. That means if the user wants to access the data from a database, they have to use the query language. Before when we have discussed the limitations of a file management system, the difficulty in accessing data we have discussed. So the difficulty in accessing data can be overcome by the query languages. So the query languages are the high level languages in which the user can request the database to retrieve the data. So in this query languages we can have 2 types of query languages. One is a procedural and another one is a non-procedural. What do you mean by the procedural query languages? If the user wants to access the desired information, they have to specify the procedures. By specifying the procedures, they are accessing the data. But in the non-procedural query language, without specifying the procedures, they are simply telling what data they need. That is the difference between the procedural and non-procedural query language. So the commercially available query languages which is supported by the Oracle is SQL, that is a structured query language. The structured query language is offering both the procedural property as well as the non-procedural property. So you just consider a pure language, that is the basics of query language. Okay, that is when the query languages comes commercially, they should follow some of the pure languages, that is the basics. So some of the pure languages are relational algebra, tuple relational calculus and domain relational calculus. The commercially used query languages called SQL is following the pure language which is called relational algebra. So now we are going to see a relational algebra. It is a procedural language. This relational algebra consists of the various basic operators like select, project, union, set difference, Cartesian product and rename. Now we are going to see the various relational operations, that is relational algebra operations one by one. So now we are going to see the various relational algebra operations. So first we are going to see the select. So what is the purpose of this select operation in a relational algebra is, from the database, that is a relational database, if we want to access the particular tuple, we are going to use the selection operation. What is the selection operation? The general syntax is so the symbol sigma can be used to denote a selection operation. So from this selection operation, we are going to select a particular tuple by satisfying some conditions. Okay. So whatever the tuple we are going to select from this select statement, these tuples definitely belongs to the given relation or a given table R. So for demonstrating this particular select operation, we are going to consider an account table. The account table consists of account number and customer ID and balance. Just for an example, A101, the customer ID is C100, the balance is 10,000. A102, the customer ID is C101, the balance is 20,000. A103, that is 104 customer, the balance is 50,000. Suppose I want to retrieve the data from this account table, like display the account details whose balance is greater than or equal to 20,000. So for this, I am going to write a select operation, that is sigma. The condition is the balance is greater than or equal to 20,000 of the table account. So this is a simple expression for a select statement in a relational algebra. By means of this statement, you can retrieve the tuple of A102 and A103, because for A102 and 103, they are having the balance greater than or equal to 20,000. So by means of this select statement, we can fetch the tuple. The next one is a project. So before we are going to see the project operation, when we are going to specifying the condition in a selection operation, we can use the other relational operators like equal to, not equal to, less than, greater than, less than or equal to. Like that we can use all the comparison operators in a given predicate. The next one is a project. The project, by means of this project statement, you can display specific columns. So a general syntax for the project is by A1, A2 are attributes. Like that you can display the n number of attributes of a relation R. So what is the general syntax denotes are A1, A2 up to AN are n number of attributes. So you can just consider this account table. I want to display the account number and balance of all customers. So for that I have to use the project statement by account number, comma, balance of a relation account. So like that I can display the specific columns. So the select statement can be used to display the specific tuples, the project statement which can be used to display the specific columns. So this select and project can be used in a single expression, that is composition of selection and projection. What do you mean by the composition of selection and projection is, I want to display the customer ID. I want to display the customer ID whose balance is greater than or equal to 40,000. So for this I am going to write a expression. The given condition is sigma, the balance is greater than or equal to 40,000 of the table is account. From this I am going to display the account number. So this particular expression is using both a projection as well as a selection. So this selection operation will retrieve the tuple of account which is balance is greater than or equal to 40,000. From this tuple we will display the account numbers. So this is the composition of the selection and projection. So the third operation is union. The third operation is the union operation. We have already studied in mathematics how the set can be involved in a union operation. Okay, suppose you just consider a set A 1 2 3 and B 2 4 5. You just consider these two sets. A union B involves 1 2 3 4 and 5. Like this we can perform the union operations, we have already studied in mathematics. Like that we can use the union operation in a relational algebra. Suppose I want to display like this, projection customer name of depositor union projection customer name of borrower. This is a simple expression for performing the union operation. This union operation will display the customer names who are all having account in a bank or loan in a bank or both the account and loan. That means the depositor table is maintaining the account detail, the borrower table is maintaining a loan detail. I want to display the customer name who is having both the loan account or either or. So that by means of this union operation we can combine the elements of two sets. We can combine the elements of two sets. And then the fourth operation is set difference. The fourth operation is set difference, that is R minus S. We know that how the difference in set theory will work. That is, when we are going to perform a difference between R and S, the set of elements available in R but not in S, that is the result of a R minus S. For example, R is 1, 2, 3 and S is 2, 4, 5. S is 2, 4, 5. You just consider this R minus S, the set of elements available in R but not in S. So what's the result? The result is 1 and 3, because the 2 is available in S. The 2 is available in S. So like that we can do the set difference. Like that for a database system, when we are going to access the people who are having the account but not a loan, who are having account but not a loan, we can write the expression. The expression is by customer name of depositor minus pi customer name of borrower. So like that I can do the set difference operation. So this is the fourth fundamental operations of a relational algebra. The next one is a Cartesian product. So for understanding the Cartesian product, I am going to consider a table, borrower and loan. So borrower consists of customer ID, loan number and amount. In loan I am having loan number, branch name and amount. Loan number, branch name and amount. So you just consider maybe I can have only loan number and branch name, loan number and branch name. Suppose when we are going to perform the Cartesian product between these two relations, what it will do is the elements are the tuples of a borrower is combined with loan. The tuples of the borrower is combined with loan. That is, you just consider the first tuple, of borrower is combined with all the tuples of the loan. Then it will take the second tuple, it will combine with all the loan relation. Just for an example, I can consider the customer ID 1, loan 100 is L100, the amount is 1 lakh. Customer ID 2, L101, the loan is 2 lakh amount. Here you just consider L100, L101, the branch name is X, the branch name is Y. Suppose you just consider the Cartesian product between these two relations, the Cartesian product between two relations, what it will do is, it will take the first tuple, so 1 L100 and 1 lakh, it will combine with L100X, L101Y. Then it will take the second L101, 2 lakh, it will combine with the two tuple L100X and L101Y. So totally we will get 4 tuple. So this is the purpose of Cartesian product. So why we are doing the Cartesian product is, when we are going to use the natural join operation, That is, for retrieval of data from more than one table, we are going for natural join operation. For performing the natural join operation, we will use this Cartesian product. So the application of the Cartesian product is using of the natural join between the two tables. And the last fundamental operation is a rename. The last fundamental operation is a rename. The notation is like this: rho x of E. So this is the basic notation, rho x of E. So what is this meaning of this rename is, any relational algebra expression E can be renamed as x. Any relational algebra expression E can be renamed as x. This expression may be a table also. Suppose for example, I can have like this. What's the meaning of this expression? The account table can be renamed as D. The account table can be renamed as D. This is the one way of doing a rename operation. Yeah, another way of doing a rename operation is like this. Any relational algebra expression E can be renamed as x, can be renamed as x. In addition to that, you can rename the attributes of the expression into a1, a2 up to an. So instead of renaming only the expression, you can rename the attributes also. This is the purpose of the rename operation. So a relational algebra consists of 6 basic operations. One is a select, another one is a project, then third one is a union, then difference, Cartesian product, and a set difference, sorry, a rename operation. So all these 6 operations can be classified into either unary operations or binary operations based on the input relations. You just consider a select, project. These are all unary operations because which will accept only one relation or only one relation as a input. So this is a unary operation. You just consider like a Cartesian product or union or set difference. These expressions or these operations may involve two relations as an input. So these operations are called binary operations. So select and project is union, sorry, the unary operation, and the Cartesian product, union, and set difference are binary operation. And finally the rename is also the unary operation because which will accept only one expression as a input, only one expression as a input. So this is the various fundamental operations of a relational algebra. So in this particular session, we have started with why we are going for a database system, then what are the different limitations of a file system. To overcome the limitations, we are just going for a database system. Next we have discussed the levels of abstractions. What are the different levels of abstractions? Then we have discussed different types of data model. By means of those data model, how we can design the database. In this data model, we have studied about the relational model as well as the ER model. And then next we have discussed about the query languages. By means of the query languages, how we can access the data, So finally, when we are going to see the applications, the database may be applied in various places. Start from universities, colleges, hospitals, banking system, and then you just consider the reservations in airline, railways. Even nowadays for the bus transport also they are using a databases. Okay, so the databases may be applied in all the places. Maybe even in the hospitals they have used the databases. So hence the databases is touching all aspects of our lives. So without database we cannot survive today. So that we will focus the concepts of database more. We will practice with the various DBMS software which is available commercially. So thank you.